Alright, y'all. So today we got composition transformation. Are you not? Yes. How can you identify the effect of composition transformation on two-metric figure? Which just reminded me, thanks DJ, I probably need to turn the volume on. We're all good.
Why do you record this?
Put it on YouTube.
You just record it one time
Guys.
a day?
Remember, we went over this yesterday. I asked yesterday, is anybody getting the links to the YouTube videos? And y'all are like, no.
You finally posted all four.
And I posted them because I realized, oh, I was seeing the links, and I was like, but then my Edmodo teacher, I saw all the links, and I posted all the links. And apparently y'all weren't seeing it, so changed it up. I saw one. Alright, anyway, we're trying to identify and draw composition transformations such as the glide reflections. We're going to be doing a lot of that today, so get ready to draw on. Okay, composition transformations and glide reflections are some of our key terms. 3, 2, 1, change. Composition of transformation. One transformation followed by another. Remember, we went over this a little bit yesterday, correct? I said, was it legal to do more than one transformation in a problem? Yes, it's legal. There's nothing illegal about it. Matter of fact, it happens more frequently than just having a single transformation. Glide reflection is something you're going to need to know. That's a key vocab word. It is the composition of a translation and a reflection across the line parallel to the translation vector. That's what we're going to be working with today. It sounds like a bunch of gibberish right now. It's really not that hard, okay? The hardest part is remembering what glide reflection is. Okay? I'm about to. Yeah, I'm about to. I'm going to let everybody write down the definition first. Okay? But I am going to do this, make sure you see and understand this definition. What two transformations are part of a glide reflection? Very good. See it? Translation and then a reflection. Okay? So that's going to be key to remember. A lot of your EOCs is vocab, just remember stuff. Calvin, you know the Calvin? So they're not dairy cows. Why are you acting like it's so weird that I see about cows? Who else has cows? DJ, you live on a farm? She just got my wife wants to. She wants to have a farm.
It takes a lot of
It all started because she started following Goats of Anarchy on Instagram. Which apparently is a life-changing thing for some people. Goats of Anarchy. Every night I get an update on this Goats of Anarchy. Whether you want it or not, you're going to get your update. Instagram. Instagram's this yeah, I know. Great guy. Goats of Anarchy. You know Goats of Anarchy? It's some lady out there that like takes goats that have bad limbs or something like that. She nurses that. Hi, how are we doing on this? I'm done. Yeah, so it's like the ones that don't have legs, she gives little wheelchair things to, or something like that. I don't know. That's what I see so far. My copy is right there. All right, y'all ready? 3, 2, 1. Come back. We need it. Whoa, boss. Thank you. You wanted an example? There you go. Okay. Yeah, I would write this down and draw the diagram. Okay. The glide. I'm so sorry. Yeah. The glide reflection that maps triangle JKL to triangle J prime, K prime, L prime is the composition of a translation along V, followed by a reflection across line L.
But the first translation be the first time in the
Well, I'm glad you asked that.
that's what
All right. So wouldn't it be that? Yes, if it wasn't a glide reflection. Remember, the glide reflection means that I've got 2 for 1, right? Let's say you go to McDonald's and order a hamburger and fries and drink, right? So you could order a hamburger and fries and a drink, and it'd be separate. Or you could order a number 1, right? Correct? And you get it all in one. So think of a glide reflection like a value scale. You get 2 in 1. Okay? Got me? Does that make sense? Glide reflection means you're going to translate and reflect. Okay? Yes, sir.
there you go.
Today you're going to see it. You're going to see it as a new plot and a reflection because it's easier to teach that way. I think it's easier to learn that way, right? But understand, this down here, this part right here, is your final image. Okay, that is your prime image. In other words, the dotted part is just part of that glide reflection. Don't think of it as the dot part is prime and this is double prime. Okay, not what that is. Okay. I get what you're saying. No, because this is a glide reflection. Okay. Good questions, guys. Really good questions. So, yesterday I said, hey, rotate it and then reflect it, right? Or something like that. Correct? And I said, think of that as prime, double prime. Glide reflections is 2 different transformations in one. Okay? What now?
It's a player. Yeah. All right. There will be a 5 votes.
I don't put lines because sometimes we do a lot of diagrams. And you got a line to your diagram. Abby, why are you tired? Not why you mad? Why you mad?
Should I make an account?
Feel like there's a space between us. Feel like there's something that's up. You gave me those nasty messages last night on that photo. I mean, hey, you know what? Y'all done? You got 4 seconds. I'll let you know that that's where that final prime is not here. I didn't have to put a squiggle. You don't have to put a squiggle. Don't put a squiggle. Yo, Megan, you done?
I'm not ready.
No, no.
Haley.
Tyler.
So you can do my first
Maybe you can do your last
one.
one.
You can do my last one, my first one.
It's all last name.
Not me. Jonesy.
How can you remember that?
You called me.
All right, here we go. Composition of 2 isometries is an isometry. That is a theorem. That is not, write it down. Go ahead and write it down. This is the part that you really should write down. The image after each transformation is congruent to the previous image. Right? This whole big concept of isometry means that things remain congruent. Shapes and sizes are the same throughout the transformation. I cannot emphasize that enough. That's what they love to ask on these tests. Yes, sir.
Like after each transformation, like what is left of the
Dilation is different altogether. That is not a rigid transformation because it's going to change its size. Dilation involves a scale factor. That's something down the road for us today. So don't even have dilation in mind just yet. Right? It does. It will. But after the next year, we'll talk more about when we get to that S word, similarities. Okay, we'll talk about dilations, the effect that dilations have on similar objects. All right, but for now, we're just on new transformations, so we can get an idea of congruency. Oh, by the way, did anybody ask a congruent question?
Very, very last.
Shall. Well, you're wrong.
Yeah,
I was really good at saying extra Josie, but right. Got it. Taylor.
Watching for the remaining.
Let's see what goes on here.
Yay.
I tell you what, why don't y'all watch first? Don't draw, just watch. Okay? Draw the result of the composition of isometry. So, whenever I hear that word isometry or isometrics, I need to think I'm going to have the exact same size and the exact same shape whenever I'm done. Okay? That's the rule of thumb. Right. The triangle KLM has vertices at 4, -1, 5, -2, and 1, -4. I first need to rotate it 180 degrees about the origin and reflect it across the y-axis. Okay, let's rotate first. Rotate first. If I rotate this 180 degrees, what do I do? What's my easy thing to do when I rotate? I can't repeat it. Remember, I know that this rotation is going to end up here somewhere, right? We got that much down. It's going to go from quadrant 4 to quadrant 2. Okay. You could turn your paper and do it that way, like you could. But good luck turning that computer screen. That's true. They are. We can just learn how to do it mathematically, and it's really not that hard. I take each of these xy's. Who was talking to me? Tyler, was it you? Okay, and what do I do with each of those?
Bottom on the third one.
No, it'll be the second quadrant, but what do I do with each of these? Take the what? Opposite. Okay, I don't have to flip the order. I just take the opposite. Yes, DJ.
Is this the one where you break the line, figures, and whatever you do the X is the same?
Nope. It's not. No. We're on the rotation first, okay? I take the opposite of x, the opposite of y. So if k started at 4, -1, it goes to -4, -1. If L goes from 5, -2, it starts at 5, -2, it goes to -5, 2. And M starts at 1, -4, it goes -1, 4. You see how I did here? Okay, K should be at -4, 1. K is going to end up at -4, 1. As soon as this board gets calibrated. Anybody have a funny joke in the next 2 seconds? Nope. That's a funny joke. That's terrible. -4, 1. That should be K. -5, 2. Should be L. And M is at -1, 4. Okay. M, L, K. That would be my 180-degree rotation, right? Here to there. See the rotation that took place? Okay. 180 degrees. Doesn't matter if I went clockwise or counterclockwise. Doesn't matter. DJ, let's get what you were saying, maybe. I then have to reflect this across the y-axis, right? Which axis is the y? Going up and down or left and right? Okay, so if it goes, reflects across it, I just have to flip this particular triangle this way, correct? And when I reflect across the y, now DJ, I take all these x coordinate points and flip them from negative to positive. My y's stay the same. Okay? You got it backwards. 4, 1, 5, 2, 1, 4. 4, 1, 5, 2, 1, 4. There is my beautiful. See, look what is today. Okay, M, L. Right, well, that would be what we're doing today. No different. It's not earth shattering. Okay, it's not too much different. This is called a composition of transformation. Not yet. Not yet. Get it? Some of it? None of it? Maybe a little. Picture. Right on. Oh, look. I think I did. Good. Thank you. Thank you. I'll be here all year, guys. Yeah. All right. So here it is. Here it is involved. Here's some steps. Rotate the image 180 degrees. Remember, I took the opposite of X, the opposite of Y. And then after I do that, I reflect the image across the Y-axis. The Y coordinates stay the same. X coordinates change. I'm taking the opposite of each. Here we go. Then I graphed it. That last part. Any questions? Okay. A little bit more. All right. Try this one. Y'all try this one. Yeah, I want you to try this one. Try it. Try it. You're going to get 3 minutes. It's going to take 3 minutes for some of y'all just to draw your graphs. You may. I don't have any. I know. Yeah, I would strongly suggest you graph it. Notice the order of the transformation. What happened? I got it. Come on up. Okay, there's the flip. Good. All right. So far, so good. Your color is. That's perfect. No, it's okay. Perfect's relative. Yeah. That's from So you flip this triangle across the x-axis, right? Flip it to a reflection. Now let's see how it is. Rotate 180 degrees about the orbit. Only
Come on, DJ.
write down the new coordinates for J, K, and L. Yeah? No, that's wrong.
These are the three right lines.
3, 0. Go, man. I don't have a lot of time. Good. Okay. All right. Now, go over here to this side of the board. Reverse all of the x and the y coordinates. Make the opposite of 3. Make it 3, 0. Okay. 4, -2. Good. -1, -off. Now, we got. Yay!
Smaller triangle.
Okay, there's our rotation, guys. He didn't quite label these. Here was L, this was K, J, okay, and I don't really have this. For positive here. Okay. Could you have just reflected it across the y-axis?
I don't even have to reflect.
Let's see here. J, there's K, right? L, this is K, J, yep. And as a matter of fact, it's one of the things that we're going to see, okay? Reflection, or reflection followed by rotation is, I don't know if it's just this particular triangle or not, but oftentimes there's more than one way to skin a cat to your transformation. How we do, guys? Still doing all right? Yeah, close to it. Okay. 3, 2, 1.
Oh, it's too much.
All right, look it up. How much of that do you write down? I would not worry about too much of that. As a matter of fact, once you think about it, more than I'll write it. Okay. Here we go. Composition of 2 reflections across 2 parallel lines is equivalent to a translation. All right, so parallel lines, right? Parallel lines. This is it. I reflected this particular triangle. Right? I reflected it once, and I reflected it again. See that? 2 different reflections. The first time, and then the second time. Over 2 parallel lines would have been the same as simply translating this triangle all the way over. Funny way of thinking about that. Okay? It says the length of the translation vector is twice the distance between the lines. Nice. That means that this particular line is twice the distance between these 2 lines. Right? We're not. These are not things that I'm going to test you on. That's why I'm not necessarily making you write this down. Composition of 2 reflections across 2 intersecting lines is equivalent to a rotation. Right? Center of rotation is the intersection of the lines. Angle of rotation is twice as much as the angle formed by the line. Okay? So, again, 2 reflections, when the lines intersect, it's the same as the rotation. Okay? I think these things are easier to visualize than they are to memorize, so let's just visualize that. Any transition, pardon me, down there at the bottom, that probably is worth writing down. Any translation or rotation is equivalent to a composition of 2 reflections. That's the part that you gotta remember. Okay, meaning translation or rotation is equivalent to a composition of two reflections. So when I say on a fill in the blank question on some sort of classwork or something like that, any translation or rotation is equivalent to a composition of blank rotation or reflection. You would, I meant two, not capitalize, not have an S on it. Okay, and you just write down two. All right. You do. You said, oh, you do. Oh, okay. I got it. That's it, guys. That's all I got. Any questions?